So here we got a nice quadratic equation problem with complex coefficients. So for solving this, we're going to use the formula of quadratic that we know. So before we start solving, let's look into the coefficients of the equation, which is a equals 3 minus 2i, b equals 1 plus I, and c is equals 2 minus I. So first I'm going to look at the discriminant of the equation, which is b square minus 4ac, and we can plug the value inside of it and we'll obtain 1 plus I whole square minus 4 multiplied by 3 minus 2I multiplied by 2 minus I. And after solving this, we can simply obtain the value of d, which is equals minus 16 plus 30i, and where d is not real, you can clearly see. And next thing is to find the square root of d, which is square root of minus 16 plus 30i. So for that, I'm going to consider our d can be written in form of some complex number square. So we can simply say that minus 16 plus 30i is equals d plus ei whole square, where d and e belongs to real. So next thing, we can simply expand the right hand side and we'll obtain d square minus e square plus 2edi. And by comparing the real and imaginary part with left hand side, we can simply say that d square minus e square is equals minus 16 and 2ed is our 30. In order to solve these two equations, we can simply plug the value of e in the first equation and we'll simply obtain d square minus 15 square upon d square equals minus 16. And after solving this further, we get a fourth degree equation, d raised to the power 4 plus 16d square minus 225 equals 0. And if we let d square as a x and d raised to the power 4 as a x square, so by applying the quadratic formula, we can simply evaluate the value of d square, which is minus 16 plus or minus square root of 256 plus 900 upon 2. And after solving this, we can simply get the value of d, which is plus or minus 3, and another imaginary value, which is square root minus 15 upon 2. So I'm not interested in the imaginary value of d, so I'm gonna take the real value, which is plus or minus 3. For that, the value of e is plus or minus 5. So we know the value of d, so by plugging the d inside the equation, we can simply obtain the value of e, which is plus or minus 5. And now we know the square root over discriminant, which is equal plus or minus 3 plus 5i. And now we are ready to apply the quadratic equation once again in our original equation. So this is our original equation, and I'm going to apply for finding the value of x, and which is equals minus of 1 plus I plus or minus, in place of root over discriminant, the value is 3 plus 5i divided by 2 multiplied by 3 minus 2i. And after solving this, we can simply obtain the two values of the x, and after rationalizing them separately, we can simply say the value of x is minus 1 plus 18i divided by 13 and minus I. So we finally obtain the two values of x, and this is a good place